In this section, we'll be solving linear equations, and then we'll progress to rational equations. So for these first few examples, I assume you guys are pretty good at this stuff, so I'm going to go fairly quickly. So starting at number 1, get my marker up and running. Okay. So starting with number 1, we've got this linear equation, 5x plus 2 equals 2x minus 10. So we'll go ahead and get our variable on one side of the equation to get 3x, and subtract 2 on both sides to get negative 12, divide both sides by 3, and solve to get x equals negative 4. For number 2, we'll go ahead and distribute. So this gives me 8x plus 4 equals 29 plus 6x minus 15. 8x plus 4 equals, combining like terms, 29 minus 15 gives me positive 14 plus 6x. Oops, 6x, there we go. And move our variable terms to one side, 2x, subtract 4 from both sides to get our constant on the right. 14 minus 4 is 10. Divide both sides by 2, and we solve and get x equals 5. All right, for number 3 and number 4, we've got fractions in these equations. So you can leave the fractions in, that's fine, and just deal with them. Or because we have an equation, we can do what's called clearing the fractions. So in order to do this, remember that our technique is that we multiply. So for clearing the fractions, you multiply both sides. So all terms on both sides by the LCD, by the least common denominator. So looking at number 3, we have a denominator of 4 and a denominator of 2. So the LCD, the least common denominator, would be 4. So I'm going to multiply all of my terms on the left and right side of the screen. Why isn't that writing? There we go. By 4. And then I can cancel, so my numerator of 4, or multiplying by 4, 4 is in the numerator, this 4 is in the denominator, those cancel out, so that gives me just x. Minus 4 times 5 would be minus 20, carry down my equal sign. 4 in the numerator divided by 2 in the denominator, leaves behind a 2 times the 1 that was already in the numerator. So x minus 20 equals 2. So we solve that and get x equals 22. And for this final example, at least on this page, we've got 3 and 2 in the denominator, so that means our LCD, least common denominator, is going to be 6. So that's the smallest number that both of those denominators divide into evenly. So I'm going to scroll down abruptly apparently. I'm going to multiply all of my terms by 3, by 6. I don't know what I was thinking there. So multiply by 6 my LCD, by 6 my LCD, multiply by 6, and multiply by 6 my LCD. All right. So 6 divided by 3 cancels to give me 2. 2 times 2x gives me 4x for my first term. Minus 6 times 5 gives me minus 30. Bring down my equal sign. I have a 6 in the numerator divided by the 2 in the denominator, which leaves behind a 3. 3 times 1 times x gives me 3x, and then minus 3 times 6 is minus 18. Move my variable terms. So that gives me x minus 30 equals negative 18. Add 30 to both sides. And this gives me x equals 12. Okay, so those 4 examples that we just saw are examples of what are called conditional equations. So this is the type of linear equation that we're most familiar with. we solve a conditional equation like 2x plus 2 equals x plus 6, for example. If we solve that, subtracting x from both sides and subtracting 2 from both sides, that would give us our solution, x equals 4. So the equation that we started with, that original equation before I messed with it, is true conditional on x equaling 4, right? It's true as long as x equals 4. Then we have equations that we call an identity, where it's true basically no matter what. X can equal all real numbers. Any real number would be a solution. So x plus 2 equals x plus 2. So if you want to think of it as solving your equation, if you, for example, tried to subtract x from both sides, then you would end up with this statement, this equation, 2 equals 2. Obviously, there's not a variable in there. 2 equals 2, that's a true statement. So when we have an equation that's an identity, so that's the type of equation, when we have an equation that's an identity, then when we're asked for the solution, we say x can be any real number. So all real numbers. So over here for our conditional equation, our solution would be x equals 4. For our identity, we can say all real numbers would solve that equation. And then for an inconsistent equation, something like x plus 2 equals x minus 1, if we go to move our variables by subtracting x, we can see that the variable goes away, and now we have an equation that says 2 equals negative 1. Obviously, that's a false statement. 2 doesn't equal negative 1 last time that I checked, because that's a false statement and the variable has gone bye-bye. We have an inconsistent equation there. It can never be true. So if we're asked for a solution, we would say there is no solution. So that would be our answer. And in case you haven't seen this before, sometimes we use these symbols or just an empty set. So 2 braces with nothing inside of them to represent no solution. All right, so usually you guys are fine with these. The only trick that I've seen students have is just determining between the identity or an inconsistent equation. And the key is when you get to this equation, do you have a true statement or a false statement? That's what I want you guys to focus on. If you have a statement that's always true, all real numbers. If you have a statement that's always false, no solution. All right, so if we take a look at 5 through 7, it says determine whether each equation is conditional, an identity, or an inconsistent equation, and we'll go ahead and write the answer as well, the solution if there is one. So for number 5, distributing, we get 3x plus 12 plus 2x equals 8x, and then distributing that negative 3, I get minus 3x, and then negative 3 times negative 4 gives me positive 12. Simplifying on either side, add my 3x and 2x to get 5x plus 12. 8x minus 3x is 5x plus 12. And at this point, you guys might be able to look at this and tell that we're going to have a situation where the left side always equals the right side, right? So we're going to have one of these identities, like a 2 equals 2 situation. So if you can tell that now at this point, that's awesome. And you can say that the type of equation that we have is an identity. Oops, wish I could spell. That's why I went into math, right? So the type of equation is identity. And then for our solution, all real numbers, right? Any real number would be a solution to this equation. So if you see it now, that's great. If you don't see it quite yet, then keep going. So maybe I want to start by moving my variable term over, but you can see that I have a 0 and a 0 on both sides, 5x minus 5x. So the result would be just this statement, 12 equals 12. 12 equals 12 is a true statement, so that's how I know I have an identity whose solution is any real number, all real numbers. All right, for number 6, let's go ahead and solve this. 2x minus 2 plus 4 equals x, and then distributing, we get minus 3x and minus 6. Simplifying on the left, 2x, and then negative 2 plus 4 is plus 2. On the right, x minus 3x is negative 2x, and then minus 6. And I'll go ahead and keep solving. So maybe I want to move my variable terms over to the left by adding 2x to both sides. So this gives me 4x plus 2 equals negative 6. And then subtract 2 from both sides. So at this point I have 4x equals negative 8. Divide both sides by 4. And that gives me my solution. That's my abbreviation for solution. X equals negative 2. So because this equation works as long as x equals negative 2, we have that conditional equation on the left-hand side. So the type is a conditional equation. All right, now moving down to number 7, I have negative 4x minus 2x equals negative 6x plus 1. And let me go ahead and move my variable term. So plus 6x plus 6x. Oops. Oh, sorry. I spaced out there. Before I do that, let me go ahead and simplify on the left-hand side. So negative 4x minus 2x gives me negative 6x. And then I have negative 6x plus 1. Now I'll go ahead and add that 6x to both sides. So negative 6x plus 6x equals 0. Negative 6x plus 6x equals 0, and then plus 1. So I end up with the statement 0 equals 1, which obviously is a false statement, or hopefully that's obvious to you guys. 0 is not equal to 1. So that gives me an inconsistent equation, meaning I have no solution. So the type is inconsistent equation. And when I'm asked for a solution, I say there is no solution.